Right, so let's have a look at how we handle raising power to a power. So we've got here our first example, 2 squared, all, I put it in brackets, all to the power of 3. Again, we need to think about what that actually really means. What's inside of our bracket, 2 squared, is going to be multiplied by itself and multiplied by itself again, because we're cubing it. So let's have a look at how that works out. 2 squared, well, we know that that is 2 times by 2. And we're cubing that, which means we're going to multiply 2 times 2 by itself and by itself again. So 2 times 2 times 2 times 2 times 2 times 2. Well, we know that that is 2 to the power of 6. So if we look at a general approach to this, again, if we look at our powers up here, 2 and 3, what we've actually done is multiplied them together to get our power, our index for our final answer, because we have 2 squared times 2 squared times by 2 squared equals 2 to the 6. So if we were to write that algebraically, we have got x to the power of n, all to the power raised to a different power of m. We multiplied our powers, so that is going to give us x to the power of n m. So let's put a little box around this one, because that's an important generalization, and we're going to use that later on when we look at some more, slightly more complex examples. Okay. So how about here, we've got a product. 2 variables multiplied by each other, a product, x, y, and we're raising it to a power, in this case to the power of 3. So it's xy all cubed. Again, if we look at what that means, it means xy. Now I'm going to actually write that out in a way that we wouldn't normally write it out in algebra. I'm going to put in the multiplication sign. X times by y. That's what we mean by xy. And we're cubing it. So we're taking that and we're multiplying it by itself and by itself again. So we've got x times y times x times y times x times y. So we've expanded that fully. And if we rearrange it, we can bring our x's and our y's together. Of course, it's a multiplication sum, so we can swap the order of things. That's fine. So I'm going to put all of my x's together. I've got x times by x times by x times by y times by y times by y. I've just rearranged it. And we can see that x times x times x, well, we know that that is x cubed times by y times y is y cubed. So now we get into the proper notation. We don't actually write that multiplication sign in there. So our answer is actually x cubed, y cubed. Okay. So if you compare that back to the question that we started with, x, y, all cubed, what we've done is we've applied that power to each individual term. We've applied it to the x to give us x cubed, and we applied it to the y to give us y cubed. So again, like we did here, let's have a look at a general version, an algebraic version of that. So if we had x, y, there's our product again, in brackets, because it's all been raised to the power of n. Okay, all been raised to a general power of n. And just like we did here, we're going to apply the power to each of the terms of the product. So that equals x to the n multiplied by y to the n, or x to the n, y to the n. Again, a really important generalization, or rule if you like there. So I'm going to put a box around that one. And now what we're going to do is we're going to use both of these things that we've just shown to attempt this fairly complex piece of algebraic manipulation, but it's a little step. It's a step further anyway. We've got a product, but each of the terms of our product is raised to a power. And then that's in brackets because everything in there is raised to the power of 4. X cubed, y squared, all to the power of 4. If we first of all bring in this part of our logic, we know that we can apply the power outside of the bracket to each of the terms inside, each of the terms of the product. So we're going to rewrite that as x cubed to the power of 4. And now we apply it to the y squared term, multiplied by, there's a little hidden multiplication sign in there in algebra, just putting it in to make the point. So now we've got y squared all to the power of 4. Remember this one? X to the n raised to the power of m equals x to the nm. This will help us tidy up over here. X to the power of 3 all to the power of 4 equals x to the power of 3 times by 4, or x to the power of 12. Multiply that by y squared all to the power of 4. Well, we know that is y to the power of 2 times by 4, which equals y to the power of 8. So our final answer, bringing everything we've looked at into one example, equals x to the 12 times by y to the 8. And I'm going to lose that multiplication sign this time. X to the 12, y to the 8. So what about if we put this into a general algebraic approach, just like we've done, and said, how about x to the power of n times by y to the m, all raised to the power of p. Therefore, we know from what we've just done here, we're going to apply that power of p to each term individually, which is going to give us x to the np, y to the mp. That is how we apply a power to a power, raise a power to a power, and even when we do it with a product.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.